Here the question is, the circuit diagram is shown below, and this is basically a network question. It's combined with transformer. Now he is asking for the power delivered by the two sources, right? So that means the power, the network is consisting of two sources here. One is pi at an angle 0 degree source, and another is 20 at an angle minus 60 degrees source, right? Now we have to solve for what is the power delivered by the two sources, right? So if you want to find out the power delivered, first we have to find out what is the current through the each and every source. So to find out the current through each and every source, first we have to represent this transformer by a network model, right? So basically this is an ideal transformer, so that's why I am writing the equivalent circuit here. So I am converting this transformer into primary side. I am shifting all these elements into primary side. That means the 16 ohms and 20 at an angle minus 60 degrees source into primary side. If you shift the 16 ohms into primary side, that has to be divided by transformation ratio square. So the transformation ratio is here 2, so we have to divide by 4. Okay, so I am writing the equivalent circuit referred to primary side. This is 5 at an angle 0 degrees, that is given in the primary side, and this is 6 ohms. Now I am shifting the 16 ohm to this side. This is 16 divided by 4, where 4 is nothing but k square. So k is 2, that's why k square is nothing but 4. So 16 divided by 4 means what? It's a 4 ohms. So I am writing 4 ohm here, and the source voltage is divided by 2, that means 10 at an angle minus 60 degrees. So this is the equivalent circuit. Now next thing is we have to find out the current. Now if I apply KVL here, minus 5 at an angle 0 degrees plus 10 into I plus 10 at an angle minus 60 degrees equal to 0. Now we have to find out I. I is nothing but 5 at an angle 0 degrees minus 10 at an angle minus 60 degrees by 10. Now if we solve for I, we will get 0.866, approximately this value is 0.866 times I. This is an imaginary current, I can say 0.666 J, right? Now this is the current. Now we have to find out the power delivered by each and every source. Now power delivered by source 1 is P1, that is V1 I1 cos phi, where phi equal what? Where the voltage here is 5 at an angle 0, I am writing in the phasor form, and the current is leading, this is 0.866, right? Now the angle between the voltage and current is 90 degrees here, so that's why P1 equal what? Vi cos phi, where V is phi and I is 0.866 and cos phi, what is the phi here? 90 degrees. So because the current leads the voltage by 90 degrees here, so that's why phi is 90 degrees. So if you solve this, we will get the power is equal to 0, because cos 90 equals 0. That's why the power delivered by the source 1 is 0. Now coming to the power delivered by source 2. Now what is the relationship between the voltage 5 at an angle 0 and 10 at an angle minus 60? So the voltage here is lags by 60 degrees. The second voltage lags by 60 degrees. So if you find out the power delivered here is V1 I1 cos phi. That means what? V1 is here, voltage is here 10 and current is 0.866, and the power factor, that is cos phi, that is equal to cos of 90 plus 60. Cos of 90 plus 60 means what? Cos of 150 degrees. If we solve this, we will get the power 7.5 watts. So P1 equal to 0 degrees and P2 equal, P1 equal to 0 and P2 equal to 7.5 watts. So the option is C. The circuit diagram is shown below. This is a transformer circuit consisting of network elements. Now he is asking for find the total power dissipated. Here the total power dissipated is nothing but the total power generation in the network. Now we can solve the total power generation. First we will convert the transformer secondary elements to primary, then we can solve the total power generation. If we transform the primary secondary elements to the primary, we will get this network. So this is the network while transforming secondary to the primary, because here the transformation ratio is 2. So if you transfer 16 ohms to the primary side, this will be divided by 4, because this has to be, the formula is 16 divided by k square, where k is 2, where k is the transformation ratio. So that's why we will get 4 ohms, and the voltage is divided by transformation ratio. So that is 20 divided by 2, that is 10 at an angle minus 60 degrees. After finding that, we will find the current, and the current is simply after applying the KVL, we will get the current, and the current is here 5 at an angle 0 minus 10 at an angle minus 60 by 10. So if you solve for this, the current will be 0.866 J. Now after finding that, we will find the value of P1 and value of P2. So the value of P1 and value of P2 is 0 watts and 7.5 watts. So this is the total power generation in the network. Now the total power generation is nothing but the total power consumption. If you have a doubt, you can solve with this. You can solve like this. The total current is 0.866 J. This is the total current. Now what is the total resistance? The total resistance is 10 ohms. Now 0.866 whole square, this is the current square, multiplied by 10 ohms is the total power loss. If we solve for this, we will get 7.5 watts. Now we can do another way also. If you sum up P1 and P2, then we will get 7.5 watts. That means always in the network, the total power generation is nothing but the total power consumption. So we can find out the total power while with the help of the voltage sources, or we can find the current, then we can find out the loss, or we can say the total power consumed, that is 0.86 whole square into 10 watts. So option is 7.5 watts. So we have to go for option B.